Hello and welcome to the Spatial Model tutorial number 4. The current video is about creating a new pair object. After you finish this video you can set up a new pair and understand what each of the basic parameters means. You can create a new pair object by clicking the open box icon. Pressing the button located third to the left will edit the currently selected object from the list. Start the pair setting by selecting the object type from the drop-down box. When you select the object type, the icon is updated accordingly. The pair object type is the default type, so when creating a new pair object, there is no need to change anything. The second step is selecting source and destination stations. Selection is made from the fields displayed on the screen. These fields contain all the stations defined in the EDS system. Selecting a station updates the list of variables associated with this station. After selecting the station, the relevant variable for the station must be selected. The selection is usually of the same variable at both stations. It rarely makes sense to examine a different variable at the source station and at the destination station. The next step is to select a tag name for the object. This is the value that will unambiguously identify the object in the spatial model system. It's important to choose a meaningful tag name. To use a tag name selected by the system, press the key located to the right of the tag name field and surrounded by the green circle. The system will display a window with a meaningful name. You can select this name or press a window close key. After selecting a tag name, select the location in the network. You can select the location from an existing list or set a new location. The selection is made from the marked field. The next step is to specify valid minimum and maximum values for a variable. Specifying values is very important so that the system does not learn from defective values records. The next item is a flow regime. A flow regime characterizes the state of the network. Many networks have different day and night regimes. For example, a central module inside the EDS system switches between different regimes. Details of how flow regimes are monitored can be seen in another tutorial. The current field indicates which flow regime is associated with the current object. An object can be associated with one or with any flow regime. When an object is associated with a flow regime, it will send alerts to the EDS system only when the flow regime is active. When the regime associated with the object is not active, the object will not generate alerts, but will continue to collect data. Sensors profile refers to the similarity between the sensors at the two stations involved in the pair. The options are: sensors are the same, sensors of the same measurement from different manufacturers, different measurements. It is important to note this field in order to allow for different reasons for measuring between stations. The delay after a regime change field determines how long after a network regime is changed, the system will start alerting events if exist. The figure is usually within minutes of the last regime change. Maximum time for a fixed value is the time that the spatial model system will treat a fixed value as a normal value. Records beyond this period will be considered improper and will not be included in the learning process. Time is stated in minutes. Learning period lag sets the time window from which records are taken for study. There are three alternatives to this window. First alternative: learning from a fixed date range. To do this, the user must set a start date and end date. Second alternative: dynamic time window denominated in days starting from current date back. A third alternative: learning from all the data available to the model. Note that the use of the third alternative can significantly extend the study time. Learning time source defines from where the model learns the delay time between stations. The alternatives are self-study, so the first option should be considered. A second alternative is learning from another pair. From our experience, we learn that measurements like conductivity or pH are more reliable for learning time delays, and therefore pairs that rely on these measurements can learn by themselves. In contrast, measurements such as chlorine or turbidity are less reliable for learning time delays, and in this case, the delay time can be taken from another pair found between the same stations. To do this, select the second alternative and mark the pair from which the measurement is taken. Once you are done, click the upper button and the database will be updated with a new table. If you click the second button, an existing object will be updated. If such an object does not exist, a new object will be created. Once the pair has been saved to the database, change its status to run mode by using the selected button. Starting from now, the Spatial Model Engine will scan the pair and will operate it when needed. We hope that this tutorial was helpful. If you have any comments, please update in our website.